Planet Earth. A planet 4.5 billion years in the making, it has cradled life in all its forms, from the first single-celled organisms drifting in ancient oceans to the vast and intricate ecosystems that now span land, water, and air. Life's journey here has been one of resilience and evolution, continuously adapting to Earth's natural rhythms. Our planet is home to towering rainforests teeming with life, to ice-capped poles that sparkle in the sunlight, to sprawling deserts whose sands whisper the secrets of time, and to the delicate coral reefs that bloom beneath the surface of the oceans. This world, full of awe-inspiring beauty and complex interconnections, has been shaped by a delicate balance, a balance between land and sea, heat and cold, light and shadow. For millennia, Earth has adapted to natural cycles of warming and cooling, to slow shifts in its climate patterns that occur over thousands or even millions of years. It has endured volcanic eruptions, ice ages, and meteor impacts, each event shaping and reshaping the biosphere. Life itself, despite these trials, has always found a way forward, evolving and adapting to the new realities that each age has brought. Yet today, something new and unprecedented is disrupting this ancient equilibrium, a force driven not by nature but by human hands. This force is global warming, a phenomenon that, while often spoken about, is still only partially understood. It has risen from our burning of fossil fuels, our clearing of forests, and our release of gases that were once sequestered deep within Earth's crust, creating an impact unlike anything in Earth's natural history. The term global warming is now a part of our everyday language, but it is often understood only in fragments, like pieces of a puzzle not yet fully assembled. Over the next hour, we will unravel the story of global warming to reveal the full picture. We'll look back to its origins in the Industrial Revolution, trace the changes it has set into motion, and understand its profound implications for the Earth and for every living being that calls this planet home. We'll dive deep into the science that underpins our understanding, examine the stakes, and confront the most pressing question of all: can humanity, with all its ingenuity and impact, step up to alter the course of our shared future? To understand the urgency of global warming, we must first examine the greenhouse effect, a fundamental and ancient process that has sustained life on Earth for billions of years. Picture Earth as wrapped in an invisible blanket made up of gases, delicately woven to capture just the right amount of heat from the sun. This blanket, thin yet powerful, contains greenhouse gases such as carbon dioxide, CO2, methane, CH4, and nitrous oxide, N2O. These gases play a vital role in maintaining Earth's temperature by trapping heat, much like the glass in a greenhouse. When sunlight reaches Earth, some of it is reflected back into space by clouds and bright surfaces, while the rest is absorbed by Earth's land, water, and air, warming the planet. As this absorbed heat is radiated back toward space, greenhouse gases capture and re-emit a portion of it, allowing Earth to retain just enough warmth to support life as we know it. This natural warming process, known as the greenhouse effect, has created conditions that allow for thriving ecosystems, diverse climates, and complex life. Without it, Earth would be an icy wasteland, approximately 33 degrees Celsius, 59 degrees Fahrenheit, colder on average, unable to sustain the vibrant life that now inhabits it. This atmospheric blanket regulates our climate with remarkable precision, acting as a buffer that maintains stability across the planet. However, in the past 150 years, a mere blink of an eye in the grand timeline of Earth, humans have altered this delicate balance. With the rise of industrial activities, we have intensified the greenhouse effect by adding billions of tons of greenhouse gases to the atmosphere each year. This shift began with the Industrial Revolution, as coal and later oil and gas were burned to fuel factories, trains, and ships. Fossil fuels became the engine of our progress, powering the growth of cities and industries. But as CO2 levels rose, so did the potential for an altered climate. Today, fossil fuel combustion, deforestation, and large-scale agriculture contribute significantly to this thickening of Earth's atmospheric blanket. Each time we drive a car, power a factory, or turn on the lights in our homes, CO2 is released into the atmosphere. Deforestation, often to clear land for agriculture or development, compounds the problem. Trees and forests are natural carbon sinks, meaning they absorb CO2 from the atmosphere. When these forests are destroyed, not only do we lose their carbon storing ability, but the carbon they once stored is released back into the air. The loss of vast tracts of rainforest and woodland amplifies the imbalance we have introduced into Earth's carbon cycle. And it's not just carbon dioxide we're adding. Methane, a greenhouse gas about 28 times more potent than CO2 in terms of heat trapping ability over a 100-year period, is released by livestock farming, rice paddies, landfills, and leaks from oil and gas infrastructure. Nitrous oxide, primarily released from fertilizers used in industrial agriculture, is even more potent, trapping hundreds of times more heat than CO2. These gases are highly effective at capturing and holding heat, meaning that even small concentrations can have a powerful warming effect. As we continue to release these gases into the atmosphere, we're effectively adding layer upon layer to Earth's blanket, trapping ever more heat and creating what scientists now recognize as an unnatural warming effect, a process we call global warming. In just a century and a half, humanity has transformed a stable, finely tuned climate system into a dynamic and accelerating source of heat. The Earth's atmosphere, once balanced, is now thicker with greenhouse gases than it has been in the last several million years. As the planet warms, we are seeing changes on a global scale that range from rising sea levels to more extreme weather events. Global warming is reshaping ecosystems, affecting water cycles, and challenging the very life systems that evolved over millennia. The full implications of this shift are still unfolding, but it's clear that Earth is moving into a climate regime unlike anything we have known in human history. This is the story we must tell, a story that connects past, present, and future. As we journey through the science and the impacts of global warming, we will confront the realities it poses and explore the ways we can change our course. The question before us is no longer about whether global warming is real, but about what we are willing to do about it. We face a moment of decision. Will we continue on this path, or will we find a way to restore the balance of our shared home? Together, we must find the answers. The scale of this change can be hard to fathom. Before the dawn of industrialization, around the late 18th century, CO2 levels in the atmosphere were approximately 280 parts per million, ppm. Today, those levels have surged past 400 parts per million, a dramatic increase when viewed in geological terms. Although it might sound like a minor rise, this difference has profoundly impacted Earth's energy balance, triggering a cascade of changes that reverberate through every part of Earth's system. Our atmosphere, oceans, glaciers, and ecosystems are intricately interconnected, and even small shifts in temperature can set off significant, often irreversible, changes across these systems. This seemingly minor change in CO2 has effectively pushed Earth's climate into a new regime, one in which familiar weather patterns, ocean currents, and ecosystems are beginning to transform. To put this shift in perspective, Earth's average surface temperature has already risen by about 1.1 degrees Celsius, 2 degrees Fahrenheit, since the late 19th century, with the majority of this warming occurring in the past few decades alone. This is more than just a number, it represents a fundamental shift in climate stability. Even a rise of 1 degree can have an enormous impact on sea levels, drought frequency, and biodiversity, altering ecosystems in ways that disrupt the balance established over millions of years. To fully understand the science behind these changes, climate scientists rely on extensive data and highly advanced models. These climate models incorporate countless variables: temperature, air pressure, wind speed, sea level, ocean temperatures, and more, gathered from a vast array of sources, including satellites, ground-based weather stations, tree rings, sediment layers, and ice cores. By synthesizing these variables, models allow scientists to simulate possible climate futures under different levels of greenhouse gas emissions. Imagine these models as virtual time machines, providing glimpses into potential futures for Earth, based on both current trends and hypothetical scenarios. What these simulations reveal is deeply concerning. The warming trend we are experiencing now is unlike any seen in hundreds of thousands of years. If current greenhouse gas emissions continue at their current pace, models predict we could see a global temperature increase of 3 to 4 degrees Celsius, 5 to 7 degrees Fahrenheit, by the century's end. While this may sound like a small number, in the context of Earth's climate systems, it represents a dramatic and rapid shift. Such a change would affect everything from global ocean currents to the frequency and severity of extreme weather events, potentially leading to widespread environmental and societal disruption. The consequences could be catastrophic, not just for ecosystems and wildlife but also for human communities worldwide. One of the most powerful sources of data for understanding past climate is found in the ice cores drilled from Antarctica's ice sheets. These ice cores serve as natural archives, storing tiny bubbles of ancient air that were trapped as snow compacted into ice over hundreds of thousands of years. By examining these trapped gas bubbles, scientists can trace historical fluctuations in CO2 and temperature, offering a vivid, detailed picture of how Earth's climate has changed over long geological timescales. What the ice cores reveal is startling. While Earth's climate has naturally oscillated between warmer and colder periods over millions of years, the current spike in CO2 and global temperatures is unprecedented in both its scale and speed. This rapid change starkly underscores the influence of human activity, which has accelerated climate change at a pace far exceeding any natural variation. The impacts of global warming are already evident, manifesting in ways we can both see and feel, with the oceans playing a central role. Covering more than 70% of Earth's surface, the oceans act as a massive buffer against rapid atmospheric changes, absorbing about 90% of the excess heat trapped by greenhouse gases. However, this vast heat absorption comes with a heavy price. As oceans warm, they disrupt marine ecosystems and contribute to increasingly extreme weather patterns. Warmer waters accelerate coral bleaching, a process where coral reefs lose their vibrant colors due to stress and can eventually die. Coral reefs, often called the rainforests of the sea, support roughly a quarter of all marine species, and their loss would have cascading effects on global biodiversity and fisheries. In addition, warmer oceans fuel stronger, more frequent storms, hurricanes, typhoons, and cyclones, as the added heat supplies energy for these extreme weather events, intensifying their destructive power. Rising sea levels are another direct consequence of global warming, driven by two main factors: thermal expansion and melting polar ice. When water warms, it expands in volume, a process called thermal expansion. Meanwhile, ice sheets in Greenland and Antarctica, as well as mountain glaciers worldwide, are melting at unprecedented rates, adding massive amounts of freshwater into the oceans. Together, these forces are causing sea levels to rise steadily, threatening coastal communities with increased flooding, erosion, and even the potential for entire regions to be submerged. Low-lying island nations and densely populated coastal cities are particularly vulnerable, with millions of people already facing the risk of displacement as rising seas inch closer each year. But global warming's reach goes beyond rising temperatures and sea levels. It's reshaping entire climate patterns, intensifying both wet and dry extremes across the globe. This shift means that in some regions, heavier, more intense rainfall events are becoming the norm, bringing with them severe flooding and landslides that devastate communities and ecosystems. At the same time, other regions face prolonged and extreme droughts, leading to water shortages that strain agriculture, reduce drinking water supplies, and make landscapes increasingly vulnerable to wildfires. Warmer air holds more moisture, allowing it to release this moisture in sudden, powerful downpours that can inundate rivers and overwhelm flood control systems. Catastrophic flooding becomes more frequent as these systems struggle to manage the intensified rains. On the flip side, hotter and drier conditions parch other areas, transforming once fertile land into arid stretches prone to massive wildfires that are more destructive and difficult to control. These changes aren't happening in isolation but are part of a larger transformation in climate systems directly influenced by global warming. From record-breaking heat waves that stretch across continents to supercharged hurricanes and typhoons that slam coastlines with unprecedented force, the impacts of global warming are expansive, touching every corner of the planet. No region is truly immune from these shifting, intensifying patterns. The effects of global warming extend to the very fabric of life on Earth, its biodiversity and ecosystems, which are increasingly under stress. Each ecosystem, from the lush rainforests and expansive savannas to the frigid tundras and vibrant coral reefs, has evolved to flourish under specific climate conditions. Species within these ecosystems have unique adaptations, shaped over millennia, allowing them to thrive in precise environments. Yet, as global temperatures rise, these ecosystems face new challenges that threaten their intricate balance. Some species, pushed to their limits, attempt to adapt, altering migration paths, changing the timing of flowering or breeding seasons, or moving to cooler and higher altitudes where they can survive. However, the pace of change is so rapid that many plants and animals simply cannot keep up, resulting in population declines and, in some cases, extinctions. This loss of biodiversity is not isolated. It has profound and cascading impacts across food webs. Every species plays a unique role within its ecosystem, and the disappearance of even a single species can trigger ripple effects, disrupting food chains, predator-prey relationships, and plant pollination cycles in complex and far-reaching ways. Global warming isn't solely an environmental issue, it's a deepening human crisis affecting every facet of human well-being, from food security and water availability to public health and economic stability. The most vulnerable populations, particularly those in low-income countries, coastal regions, and drought-prone areas, bear the heaviest burden. As sea levels rise, forcing water further inland, and droughts stretch across regions once rich with water resources, millions of people face the harsh reality of having to leave their homes, becoming climate refugees. This displacement is often permanent, altering lives and communities. In urban areas, the impacts of global warming are magnified by what's known as urban heat islands. These islands are pockets of elevated temperatures created by dense clusters of buildings, vast stretches of asphalt, and limited greenery, causing heat to linger. As cities grow, these heat islands expand, amplifying health risks for urban populations, especially for those with limited access to cooling resources like air conditioning or shaded public spaces. The elderly, children, and those with pre-existing health conditions are particularly at risk from the extreme heat that urban areas now endure more frequently. Economically, the ramifications of global warming are staggering and widespread. Climate-related disasters like hurricanes, wildfires, floods, and droughts ravage infrastructure, disrupt agricultural production, and create massive economic losses each year. As these events increase in frequency and severity, industries across the spectrum, from agriculture to insurance, feel the growing financial strain. Agriculture suffers from altered growing seasons, reduced crop yields, and, in some cases, complete crop failures, leading to rising food prices and scarcity that affect millions. Insurance companies face soaring costs as they cover the damages from increasingly common natural disasters, a cost that eventually gets passed down to consumers through higher premiums. Supply chains are disrupted by extreme weather, further inflating prices and creating shortages of essential goods. While adapting to the changes brought by global warming requires significant investments in resilient infrastructure, sustainable agriculture, and renewable energy, the economic cost of inaction is far higher. By delaying meaningful action, we are essentially deferring to a future where climate recovery will be vastly more expensive and challenging, with consequences for the stability of economies, communities, and global markets. Despite the overwhelming scientific consensus, global warming remains a topic of controversy and misinformation. Many people continue to doubt or even deny the science, raising questions about what drives this skepticism. One reason lies in psychological resistance. Accepting that our actions and way of life are causing harm to the planet can be deeply unsettling, even threatening. This discomfort leads some to seek out information that confirms their existing beliefs and downplays the severity of global warming, a phenomenon known as confirmation bias. Psychological studies show that when people encounter information that contradicts their lifestyle or values, they may feel defensive or reject it outright, which explains why some may prefer to deny climate science rather than confront it. In addition to psychological factors, powerful political and economic interests are also at play. The fossil fuel industry, one of the world's most profitable sectors, has a vested interest in maintaining the status quo. Over decades, oil, gas, and coal companies have spent billions of dollars funding misinformation campaigns designed to sow doubt about climate science, delay regulatory actions, and sway public opinion. These corporations hire think tanks, lobbyists, and public relations firms to present climate science as uncertain, casting scientists as unreliable or alarmist. Such campaigns exploit human psychology, playing into fears of economic disruption and personal inconvenience, and further fueling public skepticism. These campaigns of misinformation have had significant effects, particularly on climate policy. By questioning the science and creating confusion, the fossil fuel industry has successfully slowed the implementation of effective climate policies in many regions, allowing greenhouse gas emissions to continue rising almost unchecked. Political leaders, influenced by industry lobbying, often hesitate to pass stringent environmental regulations, fearing backlash or economic repercussions. This delay benefits the fossil fuel industry, which profits from continued resource extraction, but it comes at a grave cost to the environment and future generations. Yet, there is hope. Around the world, governments, communities, and individuals are stepping up to tackle global warming through innovative, often ambitious, solutions. Renewable energy sources such as wind, solar, and hydropower are becoming increasingly accessible and affordable, offering clean, sustainable alternatives to fossil fuels. By investing in and expanding the use of these renewable sources, we can reduce our reliance on fossil fuels and make substantial cuts to greenhouse gas emissions. In many regions, wind and solar power are now among the cheapest energy options available, driving a global shift towards sustainable energy. Other solutions include reforestation, sustainable agriculture, and conservation efforts that help absorb and store CO2 from the atmosphere. Forests act as natural carbon sinks, pulling CO2 out of the air and storing it in trees and soil. Additionally, improved soil management practices can increase soil carbon storage, further offsetting emissions and helping to balance atmospheric CO2 levels. Individuals also have the power to make a meaningful difference. By taking small but consistent actions, such as reducing waste, conserving energy, choosing sustainable products, and supporting policies that address climate change, individuals can contribute to a global movement towards sustainability. These actions, when multiplied across millions of people, create a powerful ripple effect that encourages further environmental protection and climate-conscious behavior. Each of us has a role in shaping a sustainable future, and our collective choices determine the trajectory of the planet's health and resilience. The challenge of global warming is immense, touching every part of life and demanding a unified response. But it is not insurmountable. The choices we make today will shape the future of our planet in ways we can only begin to imagine. We have seen the science, felt the impacts, and explored potential solutions. Now, the question before us is, what will we do? Together, we have the power to write a different story for our world, a story in which we protect our ecosystems, cultivate a resilient future, and ensure that Earth remains a vibrant home for generations to come. Thank you for joining us on this journey of understanding and commitment. Global warming is a challenge for us all, but it is also an opportunity for unity and collective action. The Earth is our shared home, and its future rests in our hands.